I'm Deegan Atha. I'm working on computer vision and machine learning here at the Autonomy Incubator. I'm working on object detection and classification to be used on board a UAV. So this entails using deep neural networks, specifically convolutional neural networks, to detect and classify objects within an image frame, to identify trees, other drones, human beings, so that better decisions can be made. If an obstacle is a tree, the UAV doesn't have to have any special maneuvers around it. It can land just fine. But if it's a human, that human can be moving, and being able to track and know that that's a human there, extra safety precautions will need to be taken in the navigation procedures. This is the NVIDIA Jetson TX1 board, and this is the primary board that I'm using to run the convolutional neural networks on board a UAV. And so we're able to achieve about 2 frames per second of classifying the image. So right now we have a LiDAR object detection, and this LiDAR scans in a 2-dimensional plane. So we'll know where in space an object is and what that object specifically is. And then with the tracking of the LiDAR, it spans approximately 270 degrees, which is a bigger field of view than a regular camera. And so even if the object were to leave the field of view of the camera and was still in the field of view of the LiDAR, we will still be able to know that that object is a person or another UAV or a tree. A convolutional neural network is a hierarchy of features. So as an image moves through the network, features are extracted and combined. So if you're looking out into the world and you see a tree or a human, there are several identifying features that a human could say, yes, that's a human. And this network is trained to try to figure out what those specific features are. So what makes a tree, what makes a human, identify those features, combine those features, and say, these features are a person, these features are a tree. So if you have an image, you have a set of filters that are trained, and then this image will pass through. So they have different values from their training, and so they learn different features. So the output is you could have, and so this one could have detected just like edge features here. And then if you have color, this one might have detected, there's a color splotch here, and different features as you go down. And then you pass it through more layers as you go along, and each layer then learns higher and higher level features. So then in the next one, those features could be joined together and identifying higher and higher level features until in the final layer, you have a fully connected network. You say, okay, these edges start to form into a shape of a human, which then classifies the image.